Are they right? Everyone? Yes, still it is going the epoch to find out its real learning rate. It is still going. It is not stopping, right? Because this neural network is here. It's a 4 neurons. Here it's a 3 neurons features, right? It's a here it is a 6 neurons. This is one hidden layer and two hidden layer, three hidden layer. The third hidden layer it is like 2 neurons. If I just reducing, I don't want three hidden layers. I don't want this one, and I don't want this much. Okay, now just I don't want. I just want only okay 2 features. Let's see now the classification how it is identified. So this is how it is getting transferred. They are trying to showcase how human neurons and also how this artificial neurons it is getting transformed and how the information is getting transformed to one neurons to another and also how it is going to predict the layer. Okay, so it is trying to find out its own epoch level, right? And it's already, you see, the total loss, I mean, test loss, it's 0.5. It is just stagnated. That's it. And we can stop. Okay. And the training loss, it's around 0.462. It is not changing over the, some point of operation. It is just, just simply like this. It is not improving. So we can stop at that point. It is just for understanding purposes. There is no because they are just providing if you are giving this much of I mean input if you are giving this much of input layers and this is how you can interpret the information. That is why they want to give you the simplified version of uh, neural network. Okay, so this just in your free time just go and do the play around it. Okay, we just started with activation function. Okay, sigma is one of the activation functions. Tan h, it is called hyperbolic tangent. This is the formula. The range is -1 to 1, and this is zero-centered output. It is better than sigmoid in hidden layers. Okay, but disadvantage suffers from vanishing gradient problem for large inputs. We'll see what is vanishing gradient. Later point in time. Just keep it in your mind. Vanishing gradient, that is an important one. See, ReLU is nothing but rectified linear unit. That is called as ReLU. This is the maximum no, the function, the activation function used across the neural network. So computationally efficient. So we need to see, as I said earlier, I used to say, if you are coming into the deep learning model, you should always be aware of your computational capacity. That means your infrastructure. If you are using ReLU, you don't, I mean, maximum time, you don't have to worry about the space. I mean, your graphical, the GPU. You don't have to worry about the graphics card, how much you are having. But to some extent, okay, if you are using too much of data, definitely you have to worry. And definitely you have to change. Right now, we are using 4,000 image for cats, 4,000 for dogs, totally 8,000 for training we are using. Okay, in that case, you should use a ReLU model. Otherwise, your memory will just chance of getting crash or at least because that image is very less. Each and every image it's in KB. It's not in MB. We are just reducing the oversized into smaller size, and that is how we are using this. Okay, so computationally efficient and solves vanishing gradient issue for positive values. The same again we need to consider like the simple linear regression problem, how you are identifying the MSE, right? How you are identifying the right fit during the MSE process. Same kind of a process over here. So vanishing gradient is nothing but how you are reducing the error rate or learning rate. Here, uh, yeah, we are applying the activation function value, and we are, at some point in time, this loss, it is just stagnating. It is just going in the simply sitting in the zero point 0.5 range. That means it's okay because the value should be between 0 and 1. It is just stagnating within zero point 0.5 until this. Okay. So you shouldn't take this. Maybe you can reduce it. You can, let's see here also it is 0.532. Even 56, 0.532. Let's see in 100. 113 also 0.553. So this ReLU for this model, this hidden layers, it won't be, giving you the too much of loss rate. That means the loss rate is okay. So it is giving you very good error rate, and also your accuracy also is great. So what is all about this learning rate? If I change this learning rate to 1, is there any other change? Yes, yes. Loss is 0.719. If I give learning rate around 1, the loss is around zero point 0.7. That means 70% it is getting into the loss. That means your quality is getting increased. So what is all about the learning rate? So the learning rate in a convolutional neural network or any neural network for that matter is a hyperparameter that controls the step size during the optimization process. So it determines how much the model's weights are updated in response to the error or a loss. Loss means error. Okay, error calculated for each iteration of training. Each iteration means each epoch of training. Okay, this is called learning rate. So it is just control the size, or it controls the optimization process. The small learning rate leads to slow convergence because it won't be optimized. Sometimes it will give the wrong results while detecting the object. The model may take a long time to reach the optimal solution or may get stuck in a local minimum. Okay. But if you are giving large learning rate, can cause the model to overshoot the optimal solution, leading to divergence or oscillations in the loss function. So it is about in machine learning we used to learn like if it is going beyond the control, it is a overload or underload, right? So the machine learning process, you should be balanced. That is why we are just applying the optimal technique. Optimal, I mean that is where the gradient descent comes in. Okay, so we are slowly managing and controlling the importance of the optimal solution. Here, if you are giving very small unit, that is also a problem. Very large learning rate, that is also a problem. It is a very large learning rate over here. So I wanted to control with uh, 0.1. Let's see. See, if I give zero point 0.1, 0.51 is there. If I give 0.3, same 0.57. So it is not overrated or it is not underrated. The model, if you keep the learning rate like a very very optimal solution, then if you are giving the facial detection, that model will work fine. Otherwise it won't identify the right model, I mean right image. So learning rate is an important task over here. So role in training, during training the weights of CNN are updated using an optimization algorithm like gradient. Okay, stochastic gradient descent. That is what I was saying. This is one of the optimization technique. It's very, very common in deep learning, gradient descent or gradient. So the learning rate, I'm not sure about this symbol. Okay, so scales the magnitude of these weight updates. Okay. So weights of the network, learning rate, and gradient of loss, and L with respect to the weights. Okay. It's too small, too large, it will be a problem. Okay. And techniques of optimizing, then you have to slowly increase your learning rate. Okay. Maybe from this learning rate, I'm just resetting this. See, actually, this is how we have to test. We have to go with the small and then slowly just changing it. See here itself, it is giving 0.49. Let's see how the next value reset. Okay. So here, whatever the learning rate would be, the test loss, it is coming in like this, 0.5, 0.5. So it has to, from, we have tested from this until here, this always in a range 0.5. So that is why, I mean, we can give, we can test it with this, and you can come to the decision, right? Even 0.01 is also fine for this class because it is always. But if you just suddenly change into 0.1 or 0.3, the 0.3 also is similar to 0.5, right? Okay. But if you just go to the next level, then it is loss is too much. See, even for 25 epoch is giving you 0.71. If you are going with this 3 learning rate, too much. It is going for the positive and too much of the information that model won't be good enough and it won't identify the right object detection. And this is how you have to come. This is for just for our benefit of understanding how ReLU activation function with respect to the learning rate, how it is working. So if you just consider this can be in the adaptive learning, maybe if you are learning one problem in mathematics, if you don't understand, you can go for the second iteration. If you go for the third iteration, maximum fourth or fifth attempt you will be getting it, right? Likewise, the similar kind of an attempt is happening through mathematical iterations. Okay. I stop over this and then we'll just continue and how. Yeah, this is how the convolutional and ReLU model and how and what is happening in the pooling section and what is happening with combining all these two things, the next layer, and then what is happening with the flattened and fully connected layer, and then what is happening with soft max, because we have seen this ReLU function over here for optimal solution. What is a soft max, right? I will discuss. When performing multi-class function classification, we'll be using this softmax. Mostly CNN is used for multi-class classification. It has to identify different kinds of image. So the range is 0 and 1. The sum of all probabilities is 1, right? And how the softmax is applying, there is a calculation, how it has been normalizing. Okay. So it's an applied after the final fully connected layer, and it produces a probability distribution over all classes, and it is also cross entropy loss. So we have done the entropy in machine learning itself, right? The same concept is applying in softmax, and how it is giving you the loss function or error function, and through that is giving you the converts logics into interpretable probabilities, facilitates multi-class classification by assigning a confidence score to each class. Okay, so there are limitations, but but still, softmax is a cornerstone in CNNs for tasks involving multiple classes, enabling network to make clear and probabilistic predictions. So softmax is an important function. We will see in the, I mean, by tomorrow how it has been applied, and that is how each and every layer can be identified. And just look at this matrix. Look at this functionalities. This is how each and every image has been read inside the layer. This is how the first layer, if it is a 3 by 3, or if it is 5 by 5, this just started with 3 by 3 and then slowly goes into the next layer and next layer. You see that the flow and how the value has been assigned and where it is stopped. You're just giving this image, right? This is the convolute, and that is why we're just calling this as a convoluted feature. What are all the important features that are needed in this convoluted? That is the only information that will be stored in the output matrix. Just try to understand this. Maybe I will send you this document as well to chat. And this is how it will be read. See, filter, convolved image, the edge detection, sharpen, and then all the bursts, and then box and Gaussian detection, and then it's a complete identity of the convolved image. And this is how a simple image has been identified. There's so many processes involved in each and every layer of an image, but there is one more concept called stride. So it is a number of pixels shifts over the input matrix. We'll see. Okay, so tomorrow we'll just see how it has been. Maybe you can just come up with the idea how it has been, the value has been identified and stored. Okay, and the padding, I said right, initially the beginning of this class, how the padding it will just give you the information, and then how the ReLU, rectifier linear unit is helping you to find out the pooling layer, max pooling, average, and single depth slice, and fully connected layer, how it has been identified. Okay, and how this image has been identified, futuristic maps. Okay, all the things and how it has been identified. This is the complete CNN architecture for a simple image to recognize. Okay, so this is how CNN works. Okay, so this is the process. Actually, this is the if you identify what is the pooling, the convolutional, ReLU, and again we'll just apply the pooling layer. And in fully connected layer only, it will be able to identify the object. In fully connected layer, by using softmax, in softmax, it will just identifies only the relevant information, not the irrelevant information. And that is how the output layer works. That's it. That is how it is being classified. So it is trying to identify this is cat, dog, car, truck, and this is the technique is used in the um, Tesla car, right? While on the road, it is just trying to identify which object is on the road, and it is continuously working. And softmax is there, and CNN is a fully connected layer is there, and it's very sharp to identify an object, and because it has to make a decision on its own, because you are not driving. It is taking its on its own decision. It is going and it has to identify signals, it has to identify the object on the road, and it has to stop or it has to slow down whenever the whoever is crossing the road. And there are so many things. Just imagine how I don't know. I mean, now you know the uh, importance and also the impact it is going to make in the society, and how technically it has been delighted the customer, right? Now you can see the Tesla car. Now you can see a lot of automated, the information. I will show you one more thing. I think I have shown you this object, but still, just to show, I mean, just to go and take a look at now, you will get a different perspective. This is one of the example of a rapid, example of agentic AI model. Okay. Let's see this. We'll come back tomorrow. But it is not a successful product in the market, but I would say it is a successful innovation per se. It is a successful AI agents in the market, one of the very great innovative product. But it has its own flaws, it has its own a lot of other things as well. But it is one of the great product with respect to agentic AI. This is also CNN, one of the. I mean, if you are taking that is why this CNN model is very very important because it has to identify what is happening, and this is the basic in all the facial detection, video, audio, whatever it is. This is the basic one. Let's see. Okay, any questions for today? We have seen so many things. I will share these videos. Okay, once I'm getting freed up. Luckily, we have to have a power, and we had a power so on.
How is it raining in Chennai?
Continuous.
So cyclone?
Continuous rain.
Oh. Already flooding the Velacheri area and all. Okay. It actually forecasting next 2 days, right?
That is what, yeah. Today it's huge, and today also itself, it is just.
It started raining from yesterday night.
Yeah, yesterday night, midnight onwards, it started raining.
Okay. Stay safe.
Okay, so yeah, we are, we are at the end phase of our sessions, the journey, the long journey of AML. And I will, at the end of the session, I will give you the problem statement, how you have to, do it. And I'm just, mentoring you to complete the project. So that's when the course is getting completed. Maybe session will get completed soon, but course never get completed unless and otherwise if you complete the project. Okay, ready for that problem statement to solve. And I will be there, every phase of the project. Okay, thank you so much and take care.
Thank you.
Okay, Sini.
On
Have a great day.